All right, so the goal of today's lecture is to get through the rest of this array-based list. So just, I guess, a quick reminder on how this array-based list works. So our array-based list is actually represented as a structure. So we've got our list struct up here. Now inside that structure, right, there's a pointer to the array of elements where we're going to store the elements of the list. There is a unsigned long int that represents the capacity of the array, right? So how many elements can we actually put into that array? There's an unsigned long int that represents the number of elements that are actually in the list, right? So these two things are actually different quantities, right? That's the capacity of the array. That's the number of elements that are actually in the list. Right? Now we've got a couple of init methods. Functions, a couple of init functions. So our two init functions, those are analogous to constructors in Java. Right? So what does a constructor need to do? Right? In Java, a constructor initializes the fields of your object. So when you initialize our list, right, we need to allocate space for one of these structures, right? Because I want to return one of these structures back to the caller. Right? So I need space for the structure, and then I need space for the internal array. Right, so I have to do two dynamic memory allocations. Right, so when I initialize a list capable of holding that many elements, right, I first allocate space for the list structure, right, and then I allocate space for its array. Right. When I have the memory for the array, I can set the array of the list. Right, I can set its capacity. I can set its size to 0 to indicate that it's an empty list, right? And then I can return the pointer to my structure. The list copy method is analogous to a Java copy constructor, right? So what does a constructor need to do? It needs to allocate space for the list, right? So there's our new list. I have to allocate space for the array, right? Now how big should the other array be? Well, it should have the same capacity, how big should the copied, how much capacity does the other array, does the new array need? It needs as much capacity as the old array, as the copied array. Right? So I'm going to allocate space for the new array. Right? Its size, or its capacity, is the same capacity as the other list. Right? If that succeeds, I can go ahead and set my array, right, to point to the newly allocated array. Right? And now I want to copy all the elements from that object's array. Right? So I want to copy all the elements from the other list's array into the new array. Right? So you could write a loop, right? Which would be fine. So you could write a little for loop. So I guess it would look something like for int I equals 0, I is less than other size, I plus plus, right? And then T array square bracket I equals other array square bracket I, right? But writing a loop is a lot slower than using this function called memcopy, right? So let's look at the documentation for memcopy to see what it does. Right, so memcopy copies count characters from the object pointed to by source. Right? So you pass in a, I guess we should be looking at this one. If you're wondering what restrict means, so newer, as in like C99 and after. Newer versions of C, there's this new keyword called restrict. Restrict doesn't actually, as far as the programmer is concerned, restrict doesn't do anything. Restrict is a hint to the compiler that the compiler can do certain optimizations. And other than that, I mean, so if you want to read more, if you want to know what it actually does, the Wikipedia article on restrict is surprisingly good. So if you look at that, it'll give you an example of when it would actually make a difference. But for our purposes, it's not that important, right? It's just, for us, it's just noise, right? Source is a pointer to void, right? It's a void pointer, okay? So it points at something, right? Destination, that's also a pointer to void, so it points at something. Right? What memcopy does is it copies from that array into that array. right? And it copies that many characters, right? So characters from source into destination, right? Now the units of size are characters, right? So it treats everything in your array as though it was a car or a byte, right? In other words, it treats everything as though it was 8 bits. So it just copies 8 bits at a time, that many times 8 bits of memory from here into here. Right? So if you're copying an array of int, for example, right, your count becomes the number of elements times the size of int. Right? If you're copying from an array of double, count becomes the number of elements you want to copy times size of double. Right? So in our list method, in our list function, right, I want to copy that many elements, right, times the size of int, because my element type is int. Right? I want to copy them from that array into that array. Right? And if you're copying lots of elements, then mem copies much faster than writing a loop. But after you've done that, you can set the capacity of your list. Right? So your capacity of the new list is the same as the capacity as the old list. Right? The size of the new list is the same as the size of the copied list, right? And now you filled in all of the members of your list structure, so you can return a pointer to your list. Okay? So there's your copy your quote-unquote copy constructor. Okay. Any questions so far? All right. List size is easy, right? If I want the size of a list, I can just return t-size. Right? Notice that the list, the pointer to the list, it points to a constant list object, right? Because size doesn't change. The size function should not change the list that's pointed to. Right? If I want the size of list t, I shouldn't have to change or modify anything in list t. Right? Get, right? So get should get an element out of this list t, right? And it should get the element at that index. Right? Again, right? Const is used here to indicate that the function get does not modify the list t. Right? So the first thing I do in this function is I check to make sure that the index is a valid index. Right? Now, if you use size t as your type, right? Size t is unsigned, right? Which means it can't be negative. So I don't have to check the lower bound, right? For sure, index is not less than 0. Right? So I don't have to bother checking the lower bound. I do have to check the upper bound. Right? So I have to make sure that the index is less than the size of the list, right? Not the capacity. Right? You have to check it is less than the size, right? Because size is the number of elements in the list. So I want to make sure that the index is always less than the size of the list. Right? If that's not true, then assert, assuming you have assertions turned on, will cause your program to stop. Right? And some sort of error message will be displayed. If the index is valid, it's easy, right? You just get the element at the specified index out of the array, right? And my array is t arrow arr. Right? So get's pretty straightforward. Set is also straightforward, right? Set is similar to get, except in set you're going to change the element at that index. Right? You're going to set the element at that index to elem. Right? So this function has to modify the list t, so it's not const. Right? If you put const there and try to modify the array, the compiler will tell you that there's a problem. Right? So again, validate the index the exact same way that we validated the index in get. This version of set returns the replaced element. Right? So if I replace the element at index 0, it returns the element that was at index 0 back to the caller in case they need it for something. Right? So I need to remember what is the element currently at the specified index. Right? Then overwrite that index, right? And then return the old index. Right? So set's also straightforward. Let me skip over add capacity for a second. Let's go to add. Right? And then let's skip over all of this stuff first. Right? So for add's supposed to add that element to the end of that list. Okay? So we'll just assume for the time being that our array in our list t has sufficient capacity to hold the new element. Right? So ignore the if statement for now. right? So assuming that we actually have sufficient space to store the element, then all I have to do is set the element in the array, right? What element do I set? Well, I set the element at t size, right? Because if there's no elements, if there's 0 elements in the list, right, then you want to set the index at t0, at arrays. Sorry, you want to set the array element at index 0, right? If there's 1 element in the list, then you want to set the second element in the list, right? So that's the element at index 1, and so on and so on and so forth. Right, so just go ahead and set the element at index t size to lm. Don't forget to increase the size of the list because you just added something to the list, right? And then return true to indicate that adding to the list has succeeded, right? The reason this returns true is to make it the same as the Java version of a list, right? You probably don't have to return anything here. I just decided to be consistent with Java, so I return true or false if it succeeds or if it doesn't succeed. All right, now what happens if if the number of elements in the array is equal to the capacity of the array? Right? So if there's no extra space in the array, right? So if the size of the list is equal to the capacity of the list, right, then you're out of space, right? I need to reallocate space. Right? So to reallocate that space, I'm going to call this add capacity function. Right? So add capacity is a function that that other users of the list object can't use, right? Because it's a function that's declared here. It's also declared inside, right? So it's declared inside the source code file itself, right? It's declared inside the C file itself, right? When someone uses the list. When someone uses our list implementation, they don't have access to that function, right? Because all they do is they include the header, right? Inside the header, the function add capacity is not defined, right? So the ordinary users have no idea that the add capacity function exists, right? So what does add capacity do? Well, add capacity expands the size of the array, right? What do you need to do in add capacity? So I can use realloc here, right? Now remember, realloc will allocate space, right? It'll reallocate space for the array, copying the old elements into the newly allocated array, right? So if I want to reallocate that array, and I want to reallocate that array, how big do I want to make the new array? Well, I need to make it some factor bigger than the old capacity. Right? So I'm going to take the old capacity, I'm going to multiply it by 2. Right? You can make that number 2 any number you want. Right? You can make any number bigger than 1. Right? And that will guarantee that the add function will be on average O of 1, big O of 1. Right? And then don't forget to multiply by size of int. Right? So I'm going to reallocate that array to get a bigger array. If it succeeds, if it doesn't succeed, I'm going to return false, right, to indicate that that reallocation failed. Right? Now remember how realloc works, right? If it fails, it does not modify the existing array, right? So in other words, the existing array, a pointer into the existing array is still valid. So if add capacity fails, your list is not destroyed, right? It's still usable. If realloc succeeds, I have to modify the capacity of the array, right? I then have to point, right, I then need to make ARR point to the new array, right? So I set TARR to be equal to the new array, right? And then return true to indicate that add capacity succeeded. Right? So now in add, right, I can just call add capacity if I have to. Right? If add capacity returns false, then I also return false. Right? Otherwise, at the end, I return true. Right? So after adding the capacity, you just proceed with the rest of the add method, add function. Sorry. Right? So that's how you reallocate storage for the array. Right? Now I put it into a separate function because when I implement the insert method function, right, I also sometimes have to reallocate the array. Right? So I can just call add capacity again. So insert's going to look a lot like add. Right? So ignore the stuff at the top for a second. Right? This if statement there, that's exactly the same as add. Right? If I run out of space, or if I don't have enough space to add a new element, I have to reallocate the array. So I'm just going to call add capacity. That's all the same. Right? Now, for insert, I have to move a bunch of elements to the right by one position. Right? Again, you could use a loop to do this. Right? But if you have to move a lot of elements, then running the loop is slower than if you use memmove. Right? So memmove is the function that I'm going to use to move a chunk of memory over one position to the right. Right? Now, there's an important difference between memmove and memcopy. Right? You might think I could just use memcopy, but you can't. So for memcopy, the source array and the destination array, they must not overlap. Right? So they can't overlap. If they overlap, then the behavior of memcopy is undefined. Right? The function that you want to use if the two arrays can overlap is memmove. Right? So memmove will move that many characters from starting at that pointer, right, into the memory starting at the destination pointer, right, where both the source array and the destination array are allowed to overlap, right, which is exactly the case that I'm in when I want to move elements over one position to the right. Right? I'm moving everything in the same array. Right, so what does it do? It copies count characters from the object pointed to by that to the object pointed to by that. Right? Both objects are interpreted as arrays of unsigned car. The objects may overlap. Right? So that's the important part. Right? So all I'm going to do is I'm just going to use memmove to do the move for me. Right? So how does this work? I need a pointer to the source. Right? So where, oh, I guess I should draw a picture for you. Right, so I want to move, there's my array, right? I'm going to insert at that element there, right? So I want to move all of those elements over one position, right? So I want to move those from here to here. I want to shuffle everything over one position, like that, right? So I need a pointer to that element, so that's source, right? The destination pointer is, I guess, here, right? So that's your destination pointer, right? So your source pointer then, right? I want to start moving at the given index, right? I need a pointer, so I take the address, right? I want to move it one position to the right, right? So that's index plus 1. I need a pointer, so I take its address instead. Right, if you want to write this using a pointer directly, you can write t. Let me write it on the next line for you. Shift. So I'm just going to copy this line. Right, so if you want to use a pointer instead of a index, right, then the way you would write that is as t, arr, plus index, right? And for this one, you would write that as t. Oh, what just happened? Plus, like that. Right. So those are both equivalent. Right. So the way you read that is so t arrow arr, right? That's the start of the array, right? Plus index, so that moves you to that element of the array, right? So that's a pointer to the indexed element to the element sitting at the specified index, right? So TARR, that's a pointer to the start of the array, right? Add index and then add 1, so that moves you to the next element, that points to the element next in the array. Right? So those are both equivalent. Use either one that you want, right? Don't use both, obviously, right? So use one or the other. Right. Once I've moved everything over one position, I can go ahead and set the element at that index. Right. Don't forget to increase the size by 1 because you've added something to the list, and then return true to indicate that it succeeded. Right. So that's starting from there. Right. We've taken care of that. Now, Insert has a funny, insert's slightly odd in that the index where you insert, right, you're allowed to use the size of the list as its index, right? So if you use the size of the list of the index, then that inserts at the end of the list, right? So my validation of the index is slightly different than before, right? So now I'm going to assert that index is less than or equal to the size, right? And if it's equal to the size, right, I'm just going to use add to add the elements to the end of the list, right? So in other words, I'm not going to duplicate the code in add to add the element, right? Add will take care of reallocating memory if it has to, right? So just hand off all the heavy work to add and let it add to the end of the list, right? Don't repeat yourself here. All right, any questions about insert? Right, so there's a few things going on here, right? There's dealing with having to add new capacity, right? There's dealing with moving everything over one position, right? But once you've dealt with those two problems, everything else is pretty straightforward. Okay, and now finally there's, there's remove, and then there's the two string functions. Okay, so remove is supposed to remove an element from the list, and then it shuffles everything after the element one position to the left, right? So if I'm going to shuffle everything over one to the left, right, I'm going to use mem_move again, right? So this mem_move here, I'm using mem_move to shuffle everything over after removing an element, right? So now your indexes are slightly different, right? Remember, this is the source index, right? So I'm going to start at the element one after the one I removed, right? And then I'm going to move it over one position to the left. So I'm going to move it on top of the old element that was removed, right? Remove also returns the element that was removed, right? So the first thing I do, well, I guess the first thing I do is I validate the index, right? So make sure the index is valid, right? Remember what the old element is sitting at element index, right? Calculate the number of elements that need to be moved, right? So is it possible to move no elements? Yeah, it's possible to remove no, hang on. Is it actually possible for that to be 0? T size minus index minus 1. 1, 0, 1. Why did I, oh, right. Okay, I see what's going on here. I guess if you remove something from a list of size 1, there's nothing to move, right? I guess if you remove the last element of the list, there's nothing to move. So that's what this is checking for, right? Remove the last element, then there's no copying of elements further down the list, moving them forward, right? So this, the if statement here is going to check whether or not you're removing the element at the end, right? How many elements do you have to move? Size minus index minus 1, right? Move the elements if you have to, right? Decrease the size of the list by 1 because you removed an element, right? And then return the element that you overwrote when you removed it. Okay. All right, now what about toString? So there's two versions of toString, right? Version number 1 writes into a buffer supplied by the caller. Version number 2 makes a new buffer and returns the string in that buffer. Right? So let's go through, well, I guess we'll go through this one first. So I want to generate the string representation of the list T, right? I want it to look the same as a Java list, right? So it starts with the square bracket and then has the elements of the list separated by space and a comma and a space. Right, and then has a closing square bracket at the end. Right? So if the list has size 0, then all I have to do is return that string there. Right? So I want to return that string there. But the string that I'm returning, it has to be dynamically allocated. Right? Because I can't return a local string because that local string disappears after the function finishes running. Right? So even in a little method like this where I'm returning just 2 square brackets, right, I have to dynamically allocate the array where I'm going to store the 2 brackets. right? Also notice that the size of the array that you're allocating is 1 bigger than the number of characters in the string, right? So here I'm allocating an array of size 3, right? Because my string has 2 characters in it, but you have to remember that a C string needs the trailing null terminator, right? It needs /0 as the last character to indicate that that's the end of the string, right? snprintf will print the null terminator into the string for you, right? That's why you don't see the null terminator explicitly here, right? So snprintf will print those 2 characters into the string S or into the buffer S, right? And it will add the null terminator for you at the end, right? So in other words, it will actually return a properly formatted string, right? It will only do that if there's actually enough memory in the buffer S, right? So if there isn't, so if I had allocated an array of size 2, right, and then printed those 2 characters into the buffer, right, when it adds the trailing null terminator, right, it goes 1 past the end of the array, which could cause a problem, right? But it always tries to write the null terminator. Okay, so if that's the case, then you can just return the string. Otherwise, things become a little bit more complicated, right? So the problem with the C strings is that there's no actual string class, right? Everything's just a char array. So all of the operations that you do with the string, you have to manually keep track of what's happening with that string, right? All right, so what's going on here? So I'm going to make a temporary buffer called temp. Now this is a local buffer, so whatever you do, don't return temp, right? Because if you return temp, temp doesn't exist after the function finishes, right? So what I'm going to use temp for is I'm going to figure out %d int min. All right, so what I'm using temp for is I'm trying to figure out what is the length of the longest integer value that I can print. Right? So what's the length of the longest integer value I print? Now, if you actually know what int min and int max are, you can just look it up, right, and just count the number of characters in int min and int max, right? But I didn't bother to do that. I figured I'd compute it instead, right? So I know for sure int min does not have 100 characters in it, right? It's something like 2 billion or something like that, right? Minus 2 billion-ish, right, on most desktop computing systems. Right? So I know 100 is more than enough space to actually print in an integer value. Right? I'm going to use sprintf to print int min into this buffer temp, right? Treating that value as an integer value. Right? I'm then going to ask how long is that string that's stored in temp, right? So that's the strlen function, right? So that's string length. Right, so the string length function tells you how long a string is, how many characters are in the string, not including the null terminator. Right? And so what does that tell me? That tells me how long. That tells me the maximum length of any int. Right? Because int min, that includes the negative sign. Right? So that's definitely the longest int that you have. Right? Once I know how long the longest int is, right, now I can finally compute how much space I might need in my buffer, right, in my returned buffer. Right? How many elements are in the list? Right? So there's t size elements in the list. Right? Each one of those elements, right, is followed by a comma and a space, -1, right? Because the last element does not have the comma in the space. Right? So everything that I print into the string is going to be a number, comma, space. At most, that's going to take up max int length plus 2 characters, right? I've got that many characters. Then I have the opening and closing bracket, right? And then I have the null terminator. But I'm cheating, so I could add 1 here. But I know that adding 2 here and then multiplying it by t size will take care of that, right? Because the last thing that you print into the list does not have the comma in the space. So for sure, I know that this is enough space to store any list. Right? Now notice this is something you never have to do in Java, right? Or Python. Right? You just print stuff to a string and don't worry about it. Right? But now that you're in C, you've got this problem to deal with. Right? So for sure, that buffer S will hold any list, Right? Will hold a list of any elements that I can have of length t size. Right? Now finally, I can print stuff into this buffer. Right? So how does this work? I'm going to start by making another pointer and pointing that to the front of S. Right? So P and S, they're now pointing to the same array. Right? I'm going to print the first element, right, into the array pointed at by P. Right? So pointed at by P. Right? So remember, P and S, they both point to the front of the array. Right? So S points here, and P is also pointing to the same part right now. Right? So that's your picture. Right? I'm going to print the square bracket, the first element. Is there? No, there isn't. The square bracket, and then the first element into the into my buffer S or P, whatever. They both point to the same place. Right? Oh, sorry. Control Z. Right? Okay. snprintf returns the number of characters printed to the string. Right? So it prints the, this might be a short lecture. How much battery do I have left? 25 minutes. No, we'll finish. Okay. So snprintf returns the number of characters printed into the buffer. Right? So that's n. Right? Now, so I'm going to print in some number here, right? So let's print in the number, I don't know, 1,000, 1, 2, or 100. Right, so I'm going to print in the number 100, so that's the first oh wait, sorry, hang on. Let me back up there. Square bracket, right? 1, 0, 0. Right? So snprintf is going to return 4, because I just printed 4 characters into that buffer. Right? On the next call, I need to start printing here. Right? So that's where I'm going to start printing the rest of my string. Right? So I have to advance P 4 places to the right. Right? So that's P plus 4. Right? So that's why I'm keeping track of N and P. Right? So I'm going to move P 4 spaces to the right. Right? So it points at the next free space in the buffer. Right? And now I'm going to use a loop, and I'm going to print out the rest of the elements. Right? So I treat the first element specially, because I know that the rest of the elements, when I print them out, is going to be comma space element, right? Comma space element, comma space element, comma space element. Right? That's why the first element gets treated specially. So now I can just print the rest of the elements, comma space, right? Followed by the element. Right? Keeping track of how many characters are printed each time, right? And advancing the pointer by that many elements every time. Right? So P is keeping track of where the next element starts every time, right? So you just advance P every time. Right? Finally, at the end, I can print the closing square bracket, right? snprintf will add the null terminator for me, right? And then I can return that string. Right? So generating the string representation of an object is not trivial or of a collection is not at all trivial in C. Right? Whereas if you were to do this in Java or Python, right, it's relatively straightforward. Right? Because the string classes in those languages, they take care of all this nonsense for you. Right? Whereas in C does nothing for you. Right? Almost nothing for you. It just gives you some functions and says, hey, go nuts. Right? Everything you want to do, you have to do yourself. And so you end up having to write code like this. Right? Or you go find a string library somewhere and then use the string library to take care of stuff like this. Right? But if you have to do this on your own, this is the sort of stuff you have to write. All right, any questions about that? There's a lot of stuff there, right? There's a lot of things going on inside this function. Right? There's manipulating this pointer, right? Which is going to be new for most of you. Right? There's trying to calculate how much space this thing's going to take up, et cetera, et cetera, et cetera. Right? There's a whole bunch of things going on here. It's not at all straightforward. All right, now you can avoid, well, it looks like, I was going to say you can avoid some of those problems if you don't allocate the buffer yourself. But if you look at the next version of the print of toString, it's also very long. Right? So the next version of toString returns the string in a buffer that's allocated by the caller. Right? So I'm going to generate the string representation of t. I'm going to store the string in that buffer. Right? And the caller has to tell me how much space is in that buffer. Right? So for example, if they give me an array of size 10, right, and I have a list of size 100, I can't print the entire list into that buffer. Right? So I have to stop printing before I get to the end of the buffer. Right? So now I have to keep track of how many, again have the problem of I have to keep track of how many characters are getting printed into the buffer because I don't want to overrun their buffer. Right? I don't want to print, I don't want to print past the end of their array. Right? Okay, so if their buffer size is 0, life is easy. There's nothing we can do, right? So you just return. What does this return? So this returns, right? Returns the number of characters written into the buffer, not including the null terminator, right? So that tells the caller how long their string is. Right? Okay. That's the maximum number of characters that I can write into the buffer, right? So the maximum number of characters that I can write is the buffer size minus 1, right? Why minus 1? Because I have to slap a null terminator at the end of the string, right? So the null terminator takes up 1 character, right? So I want to remember how many characters can I use, or how many characters can I print into the string, right? This thing nbuff, that's going to keep track of the number of characters written to the buffer. Right? It's unsigned type, right? So you have to be a little bit careful when you're using the unsigned type, right? Okay, so if the size of the list is 0, right, what do I want to print? Well, I want to print the square brackets followed by a null terminator into the buffer, right? Okay. I'm now going to use this function called snprintf. Right? So it's worth looking at snprintf too. Where, hopefully I have it up. All right, so number 1, notice that first of all, there's a whole bunch of these printf functions. Right? So they all do something slightly different. Right? Printf prints to standard out. Right? fprintf will print to a file. sprintf prints into a string. snprintf, right, prints into a string, but it does something slightly different. So 4, right, writes the results to a character string buffer. At most, that many characters will be written. Right? So at most, it's going to write buff size minus 1 characters into the buffer. Right? So that n is telling you that this version of printf takes in the number of characters to print. Right? The other ones don't. Right? If you don't see the n in printf, then it's not taking in the number of characters to print. Right? So snprintf behaves the same as sprintf, except there's another parameter that controls how many characters at most will be printed. Right? And this lets you prevent buffer overruns. Right? This lets you prevent writing past the end of a buffer. Right? And so that's what I want to use here, because I have this constraint that I can't write more than that many characters into their buffer. Right? So I'm going to use snprintf. Right? I'm going to print into, where is it? Sorry, I'm going to print into their array. Right? So I'm going to print into their buffer. I'm going to print that many minus 1, at most that many minus 1 characters into the buffer. Right? And I'm going to try to print those 2 characters. Right? So if they give me a buffer of size 2, right, then what will happen is you only get the opening bracket, the opening square bracket, followed by the null terminator. Right? If they give me a buffer of size 3, then I can get both of those characters plus the null terminator. Right? If they give me a buffer of size 1, then I can't get anything except the null terminator into the string. Right? Okay. nbuff, is greater than max buff. Did I do this right? If n buff is greater than max n buff, return max n buff. If n buff. So if 0 is greater than max n buff, which can't be, oh, I guess it could be, right? Okay. So I'm now going to check, right, whether or not I've written past the, if I've filled up their buffer or not, right? I think this is right. N buff is greater than, oh wait, am I doing this right? N buff, where am I keeping track? Oh, I am keeping track of n buff, okay. Did I do this one right? It is tricky to get right, so I have to, and I have a vague recollection that there's a bug in this function somewhere. And I'm trying to decide if this is correct. If n buff is greater than, oh yes, there is a bug. That's missing. There we go. Oh, drat. Sorry. Okay, there we go. All right, so snprintf is the number of characters that were printed into the buffer, right? Nbuff, that's the thing that I'm using to keep track of how many characters, of the total number of characters printed into the buffer, right? So I add n to nbuff, right? And I now check, right? Did I write, is the buffer full, right? Is the buffer that they provided me full, right? If it is, right, I return max nbuff, right? The number of characters printed to the string minus 1, right? Because the null terminator is also printed to the string, right? Otherwise, I return n, right? The number of characters, in this case, it's going to be 2, right? 2, right? I printed 2 characters into the string. So that's if the list has size 0, right? Now, if it's not size 0, you're going to repeat this code, except you're going to also write all of the other elements into the buffer. Right. So I'm using buff remaining here. Yes, there is a problem here. The type, what time is it? 2? Okay, so the type of buff remaining is size t, right? So that's an unsigned type, right? When you subtract a number from an unsigned type, you have to be very careful, right? Because if you take 1, its type is unsigned, right? And you subtract 2, you don't get minus 1, right? It's unsigned, so you get wraparound, so you get some huge number, right? So you have to be very careful about this line here, right? So whenever you're subtracting something, right? And I wonder, I'm trying to recall if this is the other, bug. Okay. Okay, so I want to remember, or I want to know how much remaining space is there in the buffer to write, right? I know how many characters I've written, right? That's the number of characters I've written in, right? I also want to keep track of how many characters are left over, right? So the number of characters that I can still have left to print into is buff remaining, right? Or buff rem, right? So I'm going to start by printing out this square bracket and then the first element of the list, right? Every time I do that, I'm going to increase the number of characters written into the buffer by n, right? I'm always checking, are the number of characters printed into the buffer greater than the maximum number of characters I can print, right? I'm then going to subtract n from buff remaining, right? This is safe here, right? The only reason this is safe is because I'm doing this check here, right? Because if that if statement's not true, right, then I know that n, well, I guess we're done. Okay, so I guess we're done for today because I have no way to recharge my laptop. So I guess we'll finish that function 2 days from now. Sorry about that. I didn't realize it was that low. But anyway, but I guess the point of today's lesson is that it's hard to do your own string manipulation in C, right? Especially when you're printing stuff and you don't know how big the things are that you're printing, right? Or how many characters that you need to print.